Okay, sir, in our last session of our DS, as part of the deep learning, we discussed about CNN. Okay, but in that, a lot of modifications are required in that session. So those modifications again, I will start this session from the scratch onwards. Okay, so that you can recall the things at the same time. The new things you will get it now. What is the modification done in the existing network? Also, you will see. Right? Better I will use that whiteboard. Is that? Already I told you one basic image. If I have some 2 by 2 pixel image, each cell is a pixel. If you say it as a PI, PI is generally greater than or equals to 0. And what is the max value within this? 255. That means each pixel value is in the range of 0 to 255, whatever the image size may be. Whether it is a 2 by 2 or 28 by 28 or 256 by 256, it doesn't matter. And there is no guarantee always like the image is a square matrix. It can be of anything even. Right? And if you take the colored image, what is the basic shape of the colored image? Again, same, the pixels within the range of 0 to 255. Again, additional 3 layers you will get it for RGB. If it is colored image, that means multi-dimensional image, you will get it. And there is a chance of negative values within our image set. Generally, as image adjustments, the operators will be doing like a sharpening, embossing, edge enhancements, edge detecting. While doing such kind of activities, you will be getting even negative values also. Okay, that means the values will be less than 0. Getting this point up to now? Suppose already in the last session I have given some basic shape of an image. Suppose there is an image like this. If it is black and white image, the what might be here into this one, like before converting into the pixel values, there are some shells. Wherever something is written, that means the shape will be like this. Remaining all the things blanks. Suppose I have the thing like this. This is what the equivalent image within this, if you elaborate this image. If you try to give a basic shape for this, that means if it is a black and white image, what is the content over here? What is the content over here? Observe my mouse movements here. Nothing. If it is nothing means there 0 will be there. 0, 0, 0, 0, 0 like this. If there is something is written in the black and white, 1 will be written. That means as part of this example, you can consider like this. You will get. That means here, as per this example, the blacks are 1s. The whites are here 0. Okay. See, first of all, what is the need of CNN? What is a convolution? And what is the need of it? Is to extract minute features. Okay. For example, one simple example. What is this? What is this? ఏదో ఒకటి చెప్పండి సార్. It's simply a man, a human you can say. It's simply a human you can say for this. Observe this, there is one more pic like this. No? Okay, treat it as a devil. But as part of the general comparisons, general classifiers, what it will say it as a man, it will say it as a man. The small features, these things will be missing. Now your network will understand both are same, both are humans. It cannot go as the second one as a devil. Why? Because here 95% similarities are same. Only one thing is extra. And as again extending this example, take a pic of human, take a pic of Mr. Warner. Except that mouth shape, except that tail, remaining all the things are same as per our photonic pictures. Understand, sir? Remaining as usual. Now your network can misunderstand as both are same. That means here some special features and minute features are neglectable here. Majority of the features matched. Definitely if you give a cat picture, an animal picture, a human picture and a devil picture, it will treat both are as human, cat as animal. If you compare with the animal and this human, there are a lot of distinguished features are there. But human and devil pictures, if you consider, minute features are different. Those minute features will be missing, cannot be understood by the networks. Especially, you are classifying the even, this is very typical. If it is a known birds, okay, one unknown bird one variety, and of the same size, of the same color, bird two variety if I give. First time if you see this, next time if you appear this one, you will treat it as this one. But in fact, there can be a lot of differences. The minute features will be missing. So that network will be misunderstanding that. That's why every feature should not be neglectable. That is what the goal of the CNN. By clubbing all these different subs of features, finally it has to classify the thing as whether it is a cat or rat or a dog or something. Whatever the classifier goal you have, that has to be achieved. Okay. So here, as part of this, what exactly the meaning of this convolution? One sample image we will take first. The input image directly should not be submitted to your ANN. If directly input image submitted to ANN, whatever the previous problem we have discussed, the problem will be repeated. That's why the input image has to be transformed as convolutional layer. The flow will be like this. The first step, it has to be transformed as convolution, not network, layer. On that convolution layer, the ReLU function should be applied. Once on the transform, this is what rectifier. Once the convolution layer has been rectified, then the max pooling, that means pooling layer has to be built. Of course, different pooling layers, sum pooling, mean pooling, max pooling. In this way, different poolings will be there. Again, if necessary, this has to be submitted to again one more convolution layer. Think that from a big image, one convolution layer may not correct. From a big image, this part will be the small feature. Again, within the small feature, again there are so many lot of other small features. Again, there is a chance of those features will be missing, right? Okay, that's why multi-level convolution layer is recommended. As image complexity is high, so many nested sub features are there. Better go with that many number of convolution layers. For this second level of this convolution layer, what is the input? The max pooled content is the input. For the first layer of convolution layer, what is the input? Your input image is the input. Again from this, again ReLU has to be applied. ReLU means rectified linear unit. What exactly is that one? In coming discussions we will see. Again, you are applying one more pooling layer. Okay, I want to start with two layers of this convolution layer. Then this has to be, the data has to be flattened. The flattened content is input to your AN. In the case of first, before convolution, directly our image is submitted to ANN. Now, instead of submitting that raw image, by dividing that image into so many sub-features, the sub-feature set is being submitted to your ANN. Once data reaches to ANN, remaining process you know. What is the process of ANN? Input layer, hidden layers, again in the final output layer. In the output layers, the classification will be done. Understand the points? Okay. Come to one single level of convolution layer. Again, the previous, the smiley symbol of pic, you just consider. I am taking one 7 by 7 pixel. That means 7 rows. One more thing. Same style. If it is a 2 by 2 matrix, that if it is a black and white picture, is a 7 by 7. Suppose let's consider previous smiley symbol. The first line is completely blank. That's why all the things zeros. Suppose this is 1 0 0 1 or else 1 like this. In this way the shape, if it is black and white picture. If it is other pictures and other things are involving 0 to 255, any other number you can get it. Again, if this image is again processed as edge cuttings and edge enhancements or edge extractions or embossing, sharpening, if such kind of operations were made on this image, you will get negative values. Understand? Okay, this is what your image basically. Previously, this image is directly submitted to, that means ANN. Within the ANN, minimum 3 layers. Input, hidden, output. That means your input image is directly flattened and submitted to input image. Okay? That means the input layer of your ANN. But now, for this ANN, we are not going to give this direct image. If I give this direct image, what will happen? What is the problem? According to our discussion, small features might be missed. Okay? That's why you are taking one feature detector. The another name for this feature detector is filter. Understand the points? Suppose, as part of the first example, my feature will be this one. Such kind of features, multiple features I will take. Now, if it is the detector, how many subsets which is equivalent to this size have been matched to this particular element? Based on that, it will construct one feature map. For this data, exactly if you count it, you will get 5 by 5 feature map. How the 5 by 5 feature map will be? In the first case, observe this. In the first case, this will be taken and comparing with this one. After that, in the second case, what it will take is, it will take this one. In this way, how many things you can write into the first line? 1, 3, 1, 2, 3, 4, only 5 you can write. That's why 5 columns here. Rows here, like columns here 7. That's why you can write 5 columns. Rows also same 5 means how many you can write? 5. Okay. So that definitely will get 5 by 5 feature map. What will be the computation into the feature map is simply element to element multiplication. So first of all, let's design 5 by 5. 2, 3, 4, 5. That's it. 5. 2, 3, 4, 5 is a 5 by 5 feature matrix. How will it be? Observe this one, sir. First element you multiply. 0 into 0. How much? 0 into 0. 0 means what? Nothing is there, right? As per our example. 0 into 0. So nothing matched. 0 into 0 again. 0. 0 into 1. 0. 0 into 1 is not 1, sir. 0 into 1 is 0. Again, 0, 0, 0. 1, 0, 0. 0. Next, third line. Compare with the third and the third. 0, 0, 0. That means everything is nothing. Nothing matched. If nothing matched, keep it 0. After that, take the second one. Take risk for the first time. Take the second one. With the same. How many things? First line 0. Second line still 0. Third line still 0. 0. Next, take this one. This part. This part you take it now. This part you take it. Again, you will get 0. Next, take this part. Still 0. Next, the final part. You take this. Still 0. Similarly, next time, take this one. This part you take it. What you will get? Zeros. Take this part again. Take this part. Still zeros. Next, take this part. One matched. Yes, one matched. In this way, everything. Suppose the 2 times matched means you will get 2. After the 0, 0, 1, 3, 0, 1, 0, 0, 0, 0, 0, 0. Let's say 1, 4, 3, 0, 0 like this. That means how many ones are there, that frequency you are writing. So here, totally how many things 5 by 5 means? 25. In how many cases this kind of behavior is appeared? 1 plus 1 plus 3 plus 1 plus 1 plus 4 plus 3. That many number of times that particular feature is repeated in that data. In that entire image. Up to now clear? So this is feature detector number 1. Such kind of feature detectors, as per our previous examples, we are triggering 7 detectors, 27 detectors. Next time, this is the first detector, feature detector number 1. Next time, it may take this one as a feature detector number 2. At the time, you will get one more feature map, right? In this way, if I choose 27 feature detectors, that means 27 filters. How many feature maps I will get? For each one feature detector, one feature map I am getting. If I select 27 feature detectors, how many feature maps I will get? Definitely 27. Now previously our image is what, sir? As per this one, what is our image? 7 by 7. Now what is our image? Your image is transformed as CN convolution layer. Now what is this? Is a 27 5 by 5 matrix. That means now it is a triple dimension, right? 27 elements. Each element is a 5 by 5. What is the advantage of this particular model is? What is the power? Like each feature, each small, if I write a 27 such kind of detectors, almost each and every part is covered over here. Understand this? Almost each and every part will be covered. With that part, how many other comparisons have been made? And all this information is available in your feature map. Now, if you write in a broad way, what will be your image? This is image. What is that size? 7 by size. What is your detector size you have selected? What is the feature detector size you have selected? 3 by 3. What is the each feature map you got? Is a 5 by 5. Such kind of things. How many feature detectors I have taken here? 27. So that what I will get here? 27 feature maps I will get. This is what CL. What is that CL? Convolution layer. Understand? That means more deeperly it has look at every image. Got it? Okay. Let's take one detector. From the detector you have taken one feature map. Now my feature map is up to now your journey. Image to feature detector to feature maps. 27 feature detectors, 27 5 by 5 feature matrices to get it. On each feature map, what is the next work to be done is, on each feature map, ReLU function should be applied. This is to safeguard of non-linearity of the image behavior. Okay, what exactly the non-linearity of the image? I will come to that discussion. For now, what exactly this ReLU will do is, observe this my feature maps. Sir, no need of writing, please concentrate over here, Mr. Sridhar sir. Please, topic is very typical. That's why I am repeating again. This is started. What is the chance of that negative value, sir, over here? What is the chance of the negative values? Suppose let's talk about only this particular third line, third row. the value is 0, 1, minus 3, minus 2, 1. Especially I told you some image manipulation things. When you do those activities, your pixel can be even negative. What this relay will do is max of 0 comma a. That's it. It won't do any computation. Suppose a value minus 3, sir. What is the 0 comma minus 3? The max of 0 comma 3? 0 comma minus 3. 0. That means what it will do? How about the third row? 0, 1, minus 3 as 0, minus 2 as 0, 1. But generally when it will happen is when you remove some content. For example, your background is this board. If I remove that board, you will get negatives. Understand, sir? There is some white color. If I remove that white, you will get negatives. Okay? That's why here simply the ReLU mathematic is different. For now, just what it is doing is max of 0 comma a. Suppose here there is a positive value called 1. Suppose 27 is a positive value. 0 comma 27 positive means 27. It remains positive as positive, 0 as 0. If anything is negative to 0, less than to 0, replacing with 0. Understand, sir? So what exactly the non-linearity of this one? Later discussion. So simply the ReLU function is applied. Once ReLU is applied, the next step is pooling layer. In the pooling layer, the max pooling will be applied. I am taking feature map number 1. In this way, I have 27 feature maps for one image. Already ReLU function is applied. This is rectified. Did you remember at the time of doing that Keras designing, the pool size we have selected 2 by 2. That means how many 2 by 2 sets here? Here how many 2 by 2 sets here? I am changing the color, just observe. This is 1, 2, 3, 4, 5. Understand? Same thing next journey. 1, 2, I'm sorry. You have to come like this. You should not consider all the taken thing, you should not touch it. You have 5 by 5 of one feature map. Let's keep some rough values here. 0, 1, 0, 1, 0, 2, 0, 1, 3, 0, 1, 0, 1, 0, 1, 0, 0, 0, 4, 5, 5, 6, 0, 0, 0, 0. This is our data. This is treated as a file. The pool size here, 2 by 2 I am taking. This is one feature map. If we treat it as a sub feature, within this, what is a highlighted feature? That is what max. What is this now? 3. From the second, what is that? 1. From the third, what is that one? 2. Again here, what is the max feature? 6. And here, 1. And next, 1. And next, 5. Next, 4. Next, 0. This is the result from, this is the max pull result from one feature map. For your image, how many such kind of feature maps are there? 27. So that how many things you will get? 27 pools you will get. Under each subset you applied max function. That's why that is called max pool. If you take average of your pool, that is what? Mean pool. If you take sum of that one, that will take, it is called as sum pool. Here highlighted feature we want. That's why max pool is applied. Totally in our MNS data set or any other thing, we have 60,000 images. Each image is a some x by x square matrix. Think that 7 by 7. For easy example, say 7 by 7. Each image is a. Now, what is this one, sir? What is the pool result? Is a set of 60,000 elements. Each element is a again subset of 27 elements. Each element is a 3 by 3 max pool sets. Understand? Okay. Once max pool is ready, up to now what are ready? Just recall your image. Image to feature detector. Feature detector to feature map. The layer of this one is called convolution layer. For this, what is applied? ReLU applied. For the ReLU content, what is applied? Max pooling is applied. How will be the result? From one image, you will get 27 max pools. This is just one image. Here, how many feature maps? How many detectors first? 27 detectors as per our example. Here, how many? 27 feature maps. Again, the ReLU result will also be without changing the dimension. Still, ReLU size is same. 27 5 by 5 rectified content. And after that, max pool is applied so that for each one feature map, you will get one separate pool content. This entire thing is simply called as pooling layer. This should be input to ANN. But how your ANN is expecting data? Flattened content or your ANN is expecting flattened content. For example, in our very beginning example, my image size is 28 by 28. So that 28 into 28, how many elements? 784. That's why in the input layer, what we have taken? 784 neurons in the input layer. Like this, once this is done, once the max pool is done, the pooling layer is done, the pooling layer has to be flattened. The flattened content should be input to your ANN. Understand, sir? For example, one main feature is like this. The sub feature is like this. Now in this case, one single level of convolution layer is okay. Image to CN to pool layer to the flattened content is to your ANN. Understanding the point, sir? Because here this is the main peak. Under that, the sub features. For example, if the thing is like this, the main feature, the sub feature, the sub feature, the sub feature. If you take this image, This is sub-feature, sir. Within this, again sub-feature, sir. Within this, again sub-features are more, sir. If such kind of things are there, still you need to go with multi-level convolution layer. If I want to involve multi-level convolution layer, now try to say image to FD. That means filters. You are applying filters directly. Directly filters means finally what is the output? Convolution layer. And after that, max pool layer. ReLU is between here. That is not a layer. ReLU is activation. Understand, sir? After that, this is submitted to ANN. But before submitting to the ANN, I want to involve multiple. Again, this has to be submitted to layer 2. Again, you will get MP. Still more sub features are there. Again, CN 3. CN 3 to again max pool layer 3. This data has to be flattened. The flattened content to be submitted to ANN. Once data reaches to the ANN, what should be done? Now, how many layers of convolution here? Layer 1, layer 2. This is layer 3. The final layer, the content, will be flattened. The flattened content will be submitted to ANN. Within this ANN, what will be there again? Within this ANN, what will be there? Input layer, hidden layer, output layer. So, when compared with ANN, what is the direct difference we are observing? In the old traditional, image directly submitted to, image is flattened content is submitted to ANN directly. So, what is the problem with that? Minute features are missing. Pardon? Nothing. For example, image 1, finally what is the result? Suppose if let's talk about only one convolution layer. What is the size of max pool layer? 27. What is the size? Pool size is 2 by 2. Output size is 3 by 3, right? Totally how many? And that means one thing is how many? If you take 1, how many? 9. 27. 27 into 9. That many neurons should be in input layer. For example, let's talk about only 3. Your max pool layer has only 3. What should be the content? Suppose max pool, the pool layer. Max pool 1, max pool content 2, max pool content 3. The data 135, 007, 012. Here 013, 130, 100. Here 1, 3, 5, 2, 7, 0, 0, 0, 5. If it is flattened, what will be the result? If it is flattened, what will be the result? Let's form first one. 1, 3, 5, 0, 0, 7, 1, 0, 1, 2. It's all the thing for first one. Same thing for second one. Same thing for second one. So that what should be the size? If each pool has 3 by 3, such kind of things I have 3 into 9. 3 into 9. That many number of neurons we have to keep in input layer. Understanding this point? In our example, 27, each layer size is 3 by 3. Now how many? 27 into 3 into 3. This is the size of input layer of ANN. It's all the story for how many images? One image. Such kind of collection set how many? 60,000 we have as per our MNS example. Got it? Once data reaches input layer, what will be done in the next? What is the ANN structure? Few neurons in input layer, few neurons in hidden layer. Still more complex operation, multiple input layer, multiple hidden layers. Finally, output. Understand the point? If I have binary classification, how many neurons are recommended? Only one is enough for me. Understand, sir? Okay. Now, the communication will be like this. Who will be passing to the next layer? These are the inputs, sir. What will be passed to the next layer? Input along with weights. Simply Wx, where W is the weights synopsis. At each hidden layer, what will be happening? At each hidden layer, what will be happening? Activation function will happen. That can be sigmoid or softmax or whatever it may be. Some activation function. Again, second layer output will be sent to the next layer. Again, next layer, the second layer will produce its own weights, right? Okay? Weights, each layer has its own bias again. These weights along with the outputs. These outputs are input to next. That means in the second hidden layer, what is the input? For the second hidden layer, what is the input? First layer output along with the weights. First layer output along with the weights. Again, in the second layer, activation function will happen or not? Happen. Again, here, the second layer outputs along with the weights will be sent to output neuron. Again, here, activation function. Understand, sir? That will be the final result of your network. Let's club all the previous things. Let's club all the previous things. Single layer convolution with simple ANN I want. Come on, try to plan your input. That means let's consider it as image. Image to convolution layer to ReLU function will be applied. Then pooling layer. Under pooling layer, each content is each element is a max pool. This is submitted. This is flattened. Then it will be submitted to ANN. My ANN contain input layer. Simple ANN means how many hidden layers? One hidden layer. Then output layer. Understand, sir? Only what is extra? For this line, this left part is extra. The traditional neural network directly submit image to ANN. Now, the pooled flattened content you are submitting to your network. Advantage of this approach? Minute feature. Okay. In the last session of our class, okay, somebody asked some more details other than the image. Try to understand, sir. You have a security system, security application. Your intention is if any hackers are trying to hack, okay, Your network has to recognize. Your deep learning securitized system has to detect it and it has to stop it. Indian is hacking, sir. Easily it will caught it. But Pakistan is hacking, sir. It cannot hack it. North Korean is hacking, sir. After hack 1 year they will detect, sir. Sir, getting my point? A Indian is hacking. Easily systems are identified. Pakistani hacking. No, understand, sir? If North Korean is hacking, understand my point? What I want to say? If you take one record, one attack, one genuine transaction, if this attack is done by North Korean and genuine transaction, there is no difference you will see. Because minute point he will touch it. That minute points cannot be recognized by direct systems, normal simple systems. If Indian hacker is attacking, Yaswing can recognize it. Pakistan hacker is hacking, ANN will recognize it. To stop North Korean kind of expert hacker also, you need to use CNN system. It's not a, don't treat it always hacking system. Treat it as a credit card fraud transaction. Who are hacking? Hacking North Korean is expert. In credit card fraud, Nigerian is expert. Understand, sir? Your bank is being attacked by your Nigerian. Then the bank system has to break it. Means if they use ANN, no, they cannot break it. They have to use CNN. Getting my point, sir? In this way, wherever you want to implement, you can implement it. The ABCD program is image detection. Okay? Later, same thing apply for your own use cases, wherever it needs. Getting the things like this. Same thing, multi-layer convolutional network with deep neural network of ANNs I want. Come on, make it. Same previous screen, convert into this type. Multi-layer convolutional neural network. Image to CL1, CL1 to max pooling layer 1. Again, this is to CL2. This is to max pooling layer 2. Content should be flattened. Flattened to ANN. Input layer, hidden layer 1, hidden layer 2, hidden layer 3, output layer. This kind of network easily can break even a complex kind of North Korean kind of hackings also. Nigerian kind of credit hackings also. Credit card frauds also. Getting the thing? More complex you are making. But how much problem is complex, how much network should be typical? That much network should be typical. Getting the thing? Okay, come back to here. Here, how this CL1 is built? How this CL1 is built, sir? By taking filters. The technical name for that one is, academic name is feature detector. Technical name for that is filter simply. By taking filter, comparing the filter for each and every part of the image. Now, what is the function is happening? Element to element, product multiplication is happening. How many times the feature is matched, that frequency it is recording into the feature map. But before feature map is generated, okay, once feature map generated, what is the next function before that max pooling? What is happening? The collection of feature maps is simply called as convolution layer. For that here, what is happening? ReLU. Two advantages you will get. What is that? Point number one, image linear or non-linear behavior, sir. Image has a linear behavior or non-linear behavior. Non-linear. That means it avoids linear behavior of the image for the classifications. Second thing, sir, suppose if I apply sigmoid instead of in the place of the ReLU, if I apply sigmoid, what will happen? What is the sigmoid output, sir? Either 0 or 1. But your pixel values are not only 0 ones, right? The value can be anything between 0 to 255, right? If sigmoid applied on the feature map, what will be missing? There is some value 246. What it will say? Whether it will replace the 246 value as either 0 or 1. That's why here definitely sigmoid kind of operation should not be applied. That is one. Okay, ReLU applied. For the ReLU output content, the rectified, what is the ReLU full forms are here? Rectified linear unit simply. That means a modified linear unit is simply called as a non-linear. Here, actual non-linear means not the non-linear. Don't compare with the non-linear regression. Understand, sir? Modified linearity of the classification simply. Then MP4. Here, what are the other types of the pools? This is max pooling. Sum pooling is there. Mean pooling is there. Median pooling is there. Different things. Understand, sir? Suppose I am taking mean pooling, sir. There are 4 people. 4 people average simply I am taking. You know, in my pool there are 4 cells. I want to keep and that particular feature as one single entity, that's it. But from that content, highlighted content I want to take. Understand the point, sir? From that picture, highlighted content I want to take. That's why max pooling. Okay? So max pooling is a subset of, definitely is a subset of feature maps. If feature map size is n, definitely max pooling size will be less than to n dimension. Got it? So if I have 20, if I want to apply 27 filters, what will be my final convolution layer size? 20 by 7. This is what convolution layer size. 27 into, according to our example, we got 5 by 5. So that how many? What will be your pool layer size again? Again 27. Again 27, which is each element is again 3 by 3. But still within that 3 by 3, again sub features are there. I don't want to miss them. One more layer. Understanding? But here the content is not flattened. Each pool directly submitted to CL2. Whatever the previous work you did for the image, for one particular pool, you have to do that work again. Sorry, our image is at 7 by 7, sir. In this case, your pool size 3 by 3, that is okay. If image is like 128 by 128, then your pool size may not be 3 by 3, right? It may be some 30 by 30, right? Understand, sir? Lot of calculation, man. First try to understand how you decide a lot of mathematical model again. If pool size 7 by 7, you are taking 3 by 3, that is okay. But if 128 by 120 image, that 3 by 3 pool is very bad, right? At the time, subset is 30 by 30. Understand the point, sir? 30 by 30. But within that 30 by 30, subcontent is there, right? Again, sub features can be there, right? I don't want to miss them. That's why Second layer of convolution. Second layer of convolution. From this you can get maybe 5 by 5. Still from the 5 by 5, minute points you want, take one more layer. In this way the journey can be proceeded. But before image, convolution layer. Once convolution layer, for the convolution layer, activation function. For the result of the activation function, you need to apply pooling layer. Without applying the ReLU, don't apply pooling. That's why in our Keras function, what we have done? Model.add. Model.add you said. What is the first you said? Convolution 3D you said. Or 2D you said. That means what type of neural network you want to implement. After that, what activation function you want. All these things you have specified or not. That is what. Understanding this one, sir. Come back to previous screen again. Now you check it. So because of my complex operation, 2 layers of convolution. Not 2 layers, 2 levels of convolution. Final layer of convolution, final layer of this one max pooling should be flattened. The flattened content should be the input to your ANN. ANN journey starts from here. Okay, now? Now, if you write in a broad picture, image 7 by 7. What is this? 27 5 by 5 feature maps. This is what? Convolution layer. For this, ReLU being applied, activation function. So that you will get 27 3 by 3 max pools. This is what? Pooling layer. This is flattened. So how many elements once it is flattened? 27 into 3 into 3. That many number of elements. This is submitted to your ANN. As part of the ANN, the input layer size should be what? Input layer size should be this one. Hidden can be depends on requirement. This is hidden layer. This is output layer. Understand this? You take this broad picture. So this is what the modification. In our last discussion, what the mistake what we did is directly the flattened content we are assigning to output layer. No, the flattened content is input to your ANN. Got it? Come on, take this broad picture. So remaining just you prepare notes by taking this video, sir. After a session, I will share this video later. Just take high level diagram, later you just prepare the notes. Sir, online team, are you following? So totally 3 steps are involving. What are those? CL, ML, CL, MP, flatten. Okay. In between the CL and MP, rail. That's it. Advantage of MP, sir. Highlighted feature. Advantage of feature maps. Touching almost all the features. Because taking from the filters right, detectors right. Okay. Advantage of ReLU. Two. Advantage of ReLU. Avoids linearity. Projecting non-linearity. Second thing, instead of ReLU, if I go with sigmoid kind of other things, I will get either 0 or 1. For non-zero, non-1 things, you cannot go right like this. But our image content will be 0 to 255. Okay, done. Let's take a break, sir. Later we continue. Online team, take a break.